Thanks, Freddie. It's a real pleasure to be here, and thanks for hosting me. Like, every time I come over here, I'm just basically sending a proposal over to Josh, and he's like, yeah, awesome, thank you. And I'm more than happy to have such an active and great Java user group over here. So it's very, very cool to see all of you here. A little bit of my background. So if you want to hear reasonable rants about Java, Java EE, not so much anymore, follow me on Twitter. That's probably the most up-to-date stream where you can find me. And as a proper German, actually I try to improve from time to time and try to see something new. And yes, I've been on the Java EE 7 expert group for how long did it last? Like 2 years to bring out that specification document and get everybody on the same table and work out the next thing, right? And at some point, I actually was tired of not only doing specifications and working as a principal architect in a German ISV of a reasonable size. So I've been doing a lot of those big Java EE projects in general. I thought there must be something else. That's definitely not what I'm dying of. Boredom or in Java EE and like doing the same stuff over and over every year, day. And EE8 is like, yeah, it's stalled. So nothing is happening. Obviously, Java EE as a platform and technology choice is kind of what everybody wants, right? Maybe. So what happened lately? Everybody started to talk about microservices, right? Isn't that amazing? Great, another buzzword. So we've been through containers, microservices, and I hear a lot of companies who actually try to imply that whatever technology you've been using so far, it's basically just cutting it a little bit differently, putting a CQRS thingy on the front end, and you're ready to roll. Like, isn't that what Netflix did? Like, it's all CQRS, HTTP, we are good to go. Like Java EE, we don't need to change a bit, right? We just keep using JPA, Hibernate, our complete stack, forget about buzzwords and microservices especially. Is that true? What do you think? Give me an opinion, give me a hand. That's true, I don't want to change a thing, I'm going to do microservices tomorrow and whatever services comes up. Thank you. Perfect, great. Not a single hand, I'm amazed. So what's the difference? What are we going to do tomorrow? .NET? Red Hat is big in .NET right now, right? Amazing, yeah, at least one hand. I don't know if it's a technology choice that we really have to make. What I really know is that actually cutting an application into pieces is something that we've been doing for quite a while. At least I did as an architect. I came across like applications that's been 10 years and older and running successfully, earning their money in production. But at some point, those things tend to get unusable. So we had to do something, like a new regulation came in. The EU, like the European Union, is super big and just rolling out new rules to every contributing country. Brexit, whoever followed that lately, right? So there are a couple of drawbacks in being in an European Union, and people actually seem to get it all wrong. But anyway, so yeah, let's say I've been working for an insurance, like a big German one, and they had a bunch of mainframes, wonderful Java EE clusters in front, everything was perfect, and they wanted to change something, and they had to change something because of a new rule. And turns out they couldn't, because the application was like cut as state of the art 10 years ago. So what did we do back in the days? We dissected everything, built out reasonable components, and made the whole thing maintainable again, right? So that's one way. Microservices itself are not new, but that might not be enough at the end of the day. So what happens right now is that after the hype curve kind of tends to go down and everybody actually started to play around with the first CQRS services, some new teensy little acronyms started to pop up, right? So CQRS is one of them. Or event sourcing, Or Spring is actually evangelizing reactive core. Like Spring is switching to something that's reactive? Jesus, I'm a Java developer. What do they mean? I mean, Java 8 actually had like a very nice streams view on collections. But that's pretty much all I know about reactive and functional programming. So I'm basically lost. And believe it or not, even if I work for Lightbend, I had to make, and I'm still in the middle of, making exactly that kind of transition. Like coming from a very classical approach, Java EE, monolithic applications, all the bad buzzwords you heard lately, towards something that is obviously better suited for today's business requirements. For maybe microservices, but maybe just a reasonable responsive architecture. So I put up a little agenda, and honestly, mostly for myself. I was asked just a couple of days ago when I started speaking, like date-wise, and I'm not really sure, but I think it must be around 2005. And the motivation for starting to stay in front of people, having that little anxiety pings and a little bit of excitement, that's not the main reason. So my main reason was I really wanted to share a little bit of what I know, right? So I sat at the computer, started that deck, and actually wanted to get to the core of what's behind CQRS especially. Who has heard about CQRS before? That's like 10 hands maybe, not even 50%. Who's using JPA, like classical Java EE stuff as of today? Okay, the other half, funny enough. So does that imply the CQRS half is actually using CQRS? Oh, not at all, like persistence. How do you guys like write applications? Okay, I probably don't want to know. Anybody. That's just a little overview what we're going to do tonight, and I'm trying to stay in the hour. We'll see how that works out. Classical architectures as of today. Let me just blend that up because we all know what's coming next. Application servers, random vendors, putting EF files in WAV files and JAR files and whatever, having a nice browser and having like a relational database behind that. Looks familiar, nice, love it. So what do we do to actually scale those kind of applications? We duplicate them. That's it, right? Isn't that easy? And mostly, all of them access like the same centralized database. Is that fun? Just name like one main problem you had with that approach. State? Like HTTP session state? For example, right? So that's where all the great commercial offerings comes in. Like WebLogic has an amazing coherence, which is another project and product you have to buy actually. That plugs in super data grid, replicates everything, no matter where your application servers are, like on the moon or in your basement. They don't fucking care as long as there's some kind of connection, right? Okay, another one.
Cognitive load.
Oh.
Cognitive load. Like, you have to know everything in order to do anything with an architecture.
It's funny because there's one thing that's not part of a Java EE specification. What is it? It's clustering. I mean, there's nothing about like enhanced clustering features in the Java EE specification. There, at least in the umbrella knot, there are a couple of like edge cases in the individual specs that are contained. But in general, there are so many features that are not really spec'd in terms of everything has to run on a single node. But all the high level will make it work in really big clustered environment things that are not part of the specification. So that's where all the vendor specific stuff comes in, right? And seriously, I've seen a lot of customers who started to struggle, especially when it came to really large installations. Random example, because I just recently read about it, PayPal. Like, who was using PayPal? PayPal, like PayPal, yeah. Who's using that? Fair. I'm German. Be creative. Don't go to sleep here. Try to be a little bit more creative in language. So yeah, they process 8 billion transactions a day. That's amazing. Would that be my first choice for a Java E cluster? And how big would that thing be? I don't know. What else do we have? Like Uber. German word Uber. You're missing like the 2 dots over the U. Jesus. English. Amazing. Like everybody's using it. And it works most of the time, doesn't it? Or Amazon, like one of the pioneers of internet shopping. They actually have orders. I don't know how many orders they process. But I'm pretty sure none of the mentioned companies, another one of my favorites is actually Twitter. None of those companies actually are using Java EE technologies. How could that be? Okay, here's a nice thing, nice question. Let's see who's reading our Lightband blog. How many VMs and how many virtual cores per VM is PayPal using to serve those 8 billion transactions a day? Make a guess. Huh?
Less than 100.
Less than 100. Anybody else? I'm German. I'm excited.
200.
200. It's getting colder, by the way.
0.
Huh?
0.
Oh. Yeah. Nice, Wade.
That's about what I heard.
It's just one big quantum computer, right?
It's 8 VMs with 2 virtual cores each.
Oh, wow.
Whoa. I know infrastructures like Java EE servers who won't be satisfied with that. Not looking at you, Big Blue. No, they got better. They have liberty and whatnot, and it's all amazing. So yeah, the idea behind all of this, like Java EE applications, I'm not actually bitching about the technology. I have to admit, I still like Java EE for many, many reasons. The APIs are pretty easy. We have a lot of developers who know what Java EE actually is. And I really like that. That's amazing. But we all have to admit that running centralized infrastructure, which has a heavy vendor-specific part that includes all the scaling and making it high available, that's probably just not the way we want to run things, especially not if operations have like the overall goal to cut like 20% of their costs every year to just make sure they stay in business. So that's where modernization comes in, and I have a couple of freaking weird animations in here that I'm definitely going to remove before I hand out the slides. So yeah, what are we going to do? Like, we slice down those monolithic applications in a reasonable way. And I get that. It totally makes sense. What also happens if we're following that microservices approach actually is that we're slicing everything, like down to the database. And that's, okay, that's fair. That gives us the ability to scale the individual parts. And we've all seen like the latest developments maybe in the classical application architecture space, getting away from those big fat Greek servers into something that's more like a fat jar and that can be easily started. And that's all perfect. We're modularizing our applications on a different level. Instead of just throwing all kinds of jar files together in a big deployment, we're actually slicing it up on the deployment side. And that's fair. Maybe it's not the right thing to do. But what we definitely see is that we end up having a bunch of different databases, and we end up having different modules. And if you look at that abstraction, that's all fair. And if you have an application that only has a couple of those modules, you know what? Using what you know as of today, what we've been all using, create, read, update, delete, JPA, whatever technologies you use to persist something in your application, it's totally fine. Forget about CQRS, forget about everything else. Just go with a reasonable fat jar approach and have fun. There's a but. This is only true for very, very simple domain models. Complex models start to run into all kind of issues. Who's still like copying value objects back and forth? I tend to do that a lot. I had my visualization objects. I had my transport objects between layers. I had my entities. That's been like, depending on the real complexity of the system, it's been like 5 times copying shit back and forth. And it's been a freaking user object, right? So nothing that, I mean, yeah, right. What else? Read versus write performance is one of my favorites, actually. And I'm not complaining about JPA in general. I'm not even think I'm complaining about relational databases at that point. But what very, very few of us actually know is the biggest drawback of relational databases. Your DBAs know. What happens if you go with a slow query and with a slow insert operation to them? What do? They tweak around, huh?
Or yelling.
Yeah, yelling is the first thing, right? Then you can go back to them with a beer and just, easygoing. So after a couple of hours, yes, I'm the bad developer, and you're the perfect ops guy and DBA, and I like you very much. He finally tells you that he can tweak the magic screws, and everything is going to be fine. Assuming you went to him with a read-only problem, he starts to tweak the read-only problem. What happens on the right side? That's your next problem. Congratulations. And then you go back, and he tweaks the right side. What happens on the read side? You have the same shit again. So relational databases can mostly only tune for very, very, very performant read operations or very, very performant write operations. There are a couple of things, views, there are workarounds that you could do, but those introduce additional complexity. Clustering situations, optimistic locking, especially when it's a very, very write-centered application. So you have a lot of changes in like a back-end module, call center agents, adding all kinds of information to user objects or whatnot. Distributed caching, like we want the shit to be performant, whatever happens. What do? We throw caches at them. Awesome, amazing idea. Hibernate second level caches, just plug them in, fire up your cluster, and you're doomed. Caches are an amazing thing and definitely one of the last tools that you want to use. Okay, and now, obviously not working. If we do things right and if we make the right decisions on the right point in time, I think this is a pretty helpful graph in general. Easy domain models, forget everything about the new stuff. Slice your applications, make them smaller, use fat jars, whatever technologies you want to do. But as soon as the complexity is starting to explode and your application is growing, you might want to look out for something new. And one of the very few new things I'm looking into here is the CQRS pattern. And I think it's actually a pattern. And it solely focuses on one single problem. Even if I've been bitching about everything else tonight, maybe that was a wheat beer. But CQRS is actually a different approach to persisting information in your applications. And it doesn't really do a lot. Like looking at it, it's a great acronym. Command Query Responsibility Segregate. This is the most hated word I've seen in a while. But what it really does is it actually separates your read side from the write side in your applications. And what we just learned, like the biggest drawback of relational databases, you can only optimize them for one. So what are commands and queries? Commands are basically something that you need for writes, and queries are something that you obviously need for reads. What I found interesting is the naming in that whole new space of CQRS. as an architectural principle, everything I'm going to show you tonight is something that you can do with a little bit more than Hibernate, for example, with a little bit more than a random JPA implementation. It's up to you. The examples I'm showing obviously are written in a different framework, but we're getting to that. But yeah, actually it's exactly that. So we're going to separate the write side from the read side. And if you take that one step further and think about commands, it's actually something that commands evolve into events. And this is exactly the part in the presentation where I'm starting to sweat a little bit, because I have nothing to bridge you into. I have no single Java EE construct that I could give you and slowly take you over into this new thinking model. CQRS is something that requires a complete different approach to architecting applications. And whoever had to do with something like complex event processing or event-driven architectures in general, those guys actually made that step forwards already. But the typical Java EE application developer, and that's somebody who I actually count myself also as, we have to take a step further and think about events and how they get handled by applications. So keep in mind, a command actually evolves into something that is an event in your application. It's no longer a synchronous call down to your database, reading or writing something, but you're starting to send events. Events have something that I hate. They occurred in the past. Events get processed and they are done. But they change your system state. So they are write operations, trigger to write operations. And whenever you see an application that is following an events-based approach, you also see that expressed in class names, variable names that actually have like a past tense. And believe me as a German, there's nothing I'm struggling more with than the English tenses. Awesome. Cargo created, leg added. Sorry, I'm really sorry. Yeah, we did something to your entities. So we have something that are persistent events. Those events are immutable facts of things that change your system state. And what we do in those CQRS-based event message-driven systems, we're keeping a big book of changes for every single entity. Whew, we still have entities. So yeah, we still have entities. It's just not a JPA entity at that point. The good thing about all of this is actually we can forget about updates. We can forget about delete operations. There's nothing ever happening. It's always going to be a straightforward write of an immutable new state. So to have a really good overview about the actual system state and everything that should be present in your individual persistent entities, you need to accumulate all the events that happened over time. It feels weird, right? So screams for a drawing. What do we have? JPA entities versus immutable facts. So from left to right. If I have a relation in an OR model, foreign keys, if I have to add a friend to somebody, and this friend gets deleted later, the actual state of the system represents nothing about the history at that point. CQRS goes a different route at that point. So what happens actually is, I have an event that captures all the new friend edit information and the friend deleted information. But it never actually deletes something. It only adds a new event at that point. And that leads to something, and I have to be a little bit careful because I'm intentionally mixing two things here. I'm about to show you a little bit more about Lagom, which is a framework you had a great talk from the tech leads about a couple of weeks ago. So I'm showing you a little bit of the microservice framework by Lightbend, which is open source and fair, so no product, no nothing. But I'm also talking about the architectural principle behind CQRS. And this is actually an overview about what Lagom does with your persistent entities. They are actually in memory, and by replaying all the events that lead to changes, they actually always have the reasonable state right now, right here. And the complete information about the past, the event log, if you like, the bookkeeping, is done in Cassandra. And it's always going to be write updates of the same information. That leads to something that I found very interesting. Actually, the current state of a system is kind of a second-class citizen because we're only dealing with updates. Yeah, that's wrong, shit. We're only dealing with immutable change facts that get locked in a very simple and very efficient way. And that's pretty cool. That's pretty cool. And that slide is actually wrong. It should say right side. So capturing the changes instead of updating the individual objects. What kind of questions can you solve with that approach? Just imagine you always have like the full set of every historical change. Have you ever been building systems that do like historical bookkeeping of changes? Mostly all of the heads are just nodding, right? That's a pain with JPA. Like making a copy of the entity, firing it in a historical table, timestamps, start to search on that. Like it's mostly going to be this big of a table. It's amazing. And what happens when I have to actually update the attributes of an entity? Like from one update to the other, the user just gets a new field, a new relation. Okay, I can normalize everything into something like JSON or XML and just put it in a blob and handle whatever I have to handle. But this is just going to be awful, right? But having all the individual changes captured in this event log allows me to actually answer questions that I didn't even know about when I was writing my application, because I can replay those individual events at any given time whenever I want to. And just a couple of examples, and it's intentionally shipping because there's a nice little demo that I built in a day, I think, and that I wrote a little mini book about. Who has heard about the cargo tracker? So Eric Evans' book, Domain-Driven Design for Experts, yeah. So he uses a very famous example, and that's called the cargo tracker application. So I started rebuilding that, and this is the reason for that kind of weird vocabulary. You actually don't have to know the questions that you want your system to answer while writing the system. And that's so weird. Up to now, I've actually only talked about the right side of the events. But we want to actually show the user something. So how do I answer questions in the CQRS architecture? For every write operation, for everything that I really want to have persisted, I need to create a reasonable read side, something that answers exactly one question. What happens here is that instead of just having the big event log and the actual state of a persistent entity, I create something in a separate table that answers exactly the question I want to have answered for the reasonable UI I'm showing to a user, for example. Let's assume I want to know which cargo actually is on which location right now. I'm actually listening to all the events that come through the system, and every event that I'm interested in, I can name them, right? We've seen that. I can actually select the events. In this case, it's cargo routed. So whenever a cargo gets rerouted, I'm listening to those events, and I'm actually splitting them out in the read side table. There are a couple of advantages to that approach, especially if you're not using logom as a framework, but implementing something like that yourself, or if you're using one of the sheer Java-based CQRS frameworks out there. You can actually pick the best database for your needs. It doesn't have to be a relational database. It doesn't have to be Cassandra. Might be it's a document-based database. So you can actually have a really free choice. And yeah, I have to admit, this is something really new, and it's really, really, really hard to dig you wrap your minds around that. If you've been blessed to work with Java EE in general, like for many, many years, what do we have? A couple of specifications, right? Standard APIs that didn't change that much. So let's dig into that. If you don't have any questions, I mean, in the meantime, just fire at will. Yeah.
I feel like optimistic locking could still be an issue that you need to handle with CQRS and event sourcing in general. Unless you just want the last event.
It's only creating new entries.
Well,
It's not changing anything.
Then you're going to have two entries that may mutate the same state twice, right?
What I forgot to mention actually is they are very, very, very inline. So they are unique, and they are replayed in exactly in exactly that order they occur in the system. So it highly depends on the database solution or the framework you use. But logom, for example, ensures that every write update for every event that happens occurs in the exact correct order and only is a new write update. So you're never going to change anything that is in a database.
Yeah, I realize that.
Mm-hmm.
How do if two people are updating that cargo location at the same exact time?
It's actually two different ones.
Well, right, but now when I read it, it's how do I pick which one of those
The last one.
So
The last one is the last event that gets replayed.
That's the same issue as any optimistic locking.
I wouldn't say so. Optimistic locking actually prevents one of the users from inserting anything. So I think the biggest advantage at that point is that you're not blocking your users from using the system. So you're shifting a little bit in terms of handling failures. Yeah.
I think the other thing that comes up a lot with Hibernate is that you're retaining a local copy of the entire object in memory, whereas with something like an event sourcing pattern, you have a very surgical edit to one file, and the event is just that key value pair that's being updated. And so, like, if you have that running in an actor, then it will replay it.
That's a technology choice. I mean,
Yeah.
again, the CQRS as an architecture is something that you can use in whatever you want to use it. Just implement it as an architectural approach. And I have a couple of more pointers, so for everybody who wants to dig in. I think Microsoft did a lot of research on that, and they have a very good journey book, The Journey to CQRS. So whenever you have a couple of minutes, it's going to be hours, by the way.
Yes, going back to the last example,
Mm-hmm.
it sort of makes you think about how it's going to be used when you design it, right? So I thought earlier you had mentioned that it will be transparent to you, but when I look at the previous example, you have to sort of know.
You're looking at that one?
How it's going to be used, because otherwise I would end up creating this records in the table.
You usually create one read side to answer one exact question. So you really need to know which question you want to be answered. Yes, you have to think about that. And I'm going to actually show you the code for an example read side, and that makes it easier. Yeah.
Typically with this kind of architectural pattern, since you have event-driven development or event-driven application, you typically would put that on a cluster and have multiple nodes be able to handle updates like that.
Mm-hmm.
How can you resolve the current state to handle complex rules to say, if you send in a message to say that the location's been updated, that it may affect other things that deal with the current state? Because all those nodes are not always up to date. And also then your your storage object that you're throwing against?
It's a very quick and dirty answer. It highly depends on how the underlying framework, the events framework, actually handles that. Speaking for Lagom, I'm actually talking about that a little bit later on. I think that's the biggest issue if you want to use anything else, like want to try to implement that CQRS pattern on top of Java EEC, for example. So there is no real events processing mechanism that is reliable, knows about clustering situations. So that's a big part of what you need to have as a foundation in general. Agree?
Yeah, so you talked about kind of denormalizing your reads
Mhm.
in a way.
Yeah.
Creating like maybe even across different data stores, depending on the query patterns that you need. How does like almost like transactional integrity come into play? Like you just sort of say, I don't care about that, or like where's that come in?
The funny part is the read side doesn't give a shit about transactions. It is a throwaway side of your application. It can be recreated in any given point of time just by replaying the events log.
More concretely, like if I were writing like more of a financial system, like I'm processing credit card transactions, let's say, like, and I want to show you your current balance.
That would all be rolled into one command stack, right? So like any transaction update would have like, withdraw as the command, and then a series of atomic events that would be rolled back on the right side. So you're still, like, but I wouldn't implement a banking system in Cassandra.
So I actually implemented a system like that. I worked in a system that for 10 years. And when we solved that, we had a checkpoint. We knew the balance was true at like 3:30 in the afternoon because there's some regulations that we did. And any other delta between that was replay the transfer.
So the funny part of this talk is actually it's only showing a very, very low level part of applications that have to be designed in a different way. And I'm not saying in no way that CQRS itself as an architectural concept is enough to solve your problems. You definitely need to think way beyond that. You need to think about reactive applications. You need to think about the complete events processing mechanism. There are a bunch of frameworks out there that you could use it with easily. Akka was like named already. Lagom supports it like natively. It's built in. I have no idea what Spring/Pivotal is doing on that end, but looking at Reactor, I think they're slowly moving into that direction. But yeah, it's only one piece, like it's a puzzle, the whole thing. Designing applications, especially reactive applications, needs more than just CQRS. I was just especially curious about that. Yeah, sorry.
Will you be going to the difference between CQRS and event sourcing?
Again?
I'm not clear on the difference between event sourcing and CQRS.
Yeah, I haven't worked that out totally. You can. Yeah, it's not in the slides that what I'm saying. So you can use CQRS without event sourcing. It's just not that efficient, and it's not really working. I think the way where commands automatically blend into events is exactly the bridge between CQRS and event sourcing. And I'm not looking into event sourcing in that part because I'm not looking into the event system underneath. Lagom provides it as a framework, and we're using Cassandra as a database. But there are so many other implementations out there, even like plain Java SE implementations, and they're all handling it differently. And I didn't want to look into the event sourcing part that much. Just want to give you the bridge into CQRS at that point.
I mean, isn't CQRS just treating queries and commands separately? So you could write via JPA, but you're going to query via view. Your view is nothing more than your aggregation or projection of entities.
Perfect. Projection is something that is probably a very good term to use for that. Absolutely.
I thought CQR, or a shorter version of the acronym, was something that has existed for like 20 years for people who did software engineering research. And then this .NET guy, whoever, I forget his name,
Yeah.
Greg, someone came up with CQR.
20 years, I'm getting old.
He did add something on top of it, and I'm just not clear what separates modern CQRS from command and query separation, segregation from years ago?
Again, I can't comment at all. I have a couple of more slides, further readings and links. I personally really enjoyed the CQRS journey, which is exactly what you're referring to. I think that gives a much more complete overview. What's the biggest drawback for that kind of presentations? It's like 60 minutes at most. So I had to make a cut at some point.
I take on your question about CQRS command and QRS separation is of the functional programming side of things. So whenever it's about the referential transparency, so by this, every time you query the system, that function should never change the state of that system. So now if you imagine the system to be on a physical level, now your architecture, will also separate those commands and those queries.
Okay, let's at least try to look briefly into the cargo tracker. It's as simple as it looks like. I mean, the original cargo tracker isn't. There are a bunch more modules, but this is exactly where I started out, and it's been literally done in less than a day, just to give you a brief idea about how that works with Lagom. It looks super easy. It has basically, I think, 3 features up to now. And what I did, I added like a simple read site to this application. And believe me, the Lagom framework guys in Lightband aren't really happy about that because I did something that is not exactly perfect. So the registration HTTP post call here is something that just adds like the cargo information from this UI into the system. And the REST call, the read side here, lists potentially all cargoes in the system. That is definitely not a good way to do it. It could be millions of. So just to give you a little bit of context, it was designed and thought about to just show you how to do it and not how to do it best. So cargo entity, at least in Lagom, the persistent entity is the root of everything that we are working with. And those entities actually, they give you a state. It represents a state. It defines the events. So state in that terms is the payload. And it also links to the commands that it can handle that come in here. The right side is pretty easy. In this example, which is again super Lagom specific, you basically persist the entity, the event that persists something in your event log. Jesus, I'm still like struggling myself as a Java E developer. And this is literally all you have to do. The rest is handled for by the system in general. What is a lot more complicated, I mean, this is something that I can kind of follow. So there's a registration command that's defined in the application, and after that, I actually know that the cargo is registered. So the event is processed. The read side actually needs a lot more. Because whenever we have to recreate one of those entities, we need to, and actually have to read out all the events going through, we need to first create the correct views, the perspectives that we want to project our events into to answer our one specific question. We actually need to write the individual events that go through the system. And that's exactly a couple of steps that you have to implement. And the link to the source code actually was intentionally, so you really need to look into that. I see some questions upcoming.
Yeah.
No?
What is this?
What is this?
The process.
Those are, the cargo event processor actually processes the events that are actually handled, right?
They are generated by the commands.
Correct.
So they're, okay.
And the cargo processor also has a bunch of preparation work to do, setting up the tables for the read side.
On the command side.
This is, I think
That's the processor.
This slide is
Oh,
displayed,
okay.
right? It's the right side preparation.
No, it's a read side preparation, not the right side preparation. The right side is completely handled by logom, and that's it. So we're now starting to prepare the actual read side of the equation.
You're
And
reading to the tables or the data stores.
Correct.
So that you then can query from?
that what?
If I'm reading this right here, prepare write cargo, is that like writing to your cargo data stores so that you could then query from?
Producing the SQL table, the database table that actually holds your answers for that you want to have answered, correct?
Okay, so
Just curious about the create tables in terms of concurrency. Two users are using it. You really have to create tables for each.
For each answer that you want to have answered, you need to create a separate read side. That's true. And the framework, in this case, it's again logom, make sure it is executed synchronously, especially the preparation phase. And it only happens once, right? So we're not talking about executing it all over again. I just want to, this slide has just one meaning, and I wanted to show you what steps it takes. The actual source code names, the class names, where to dig into, are just beyond the headline. And what I do in my talks is I give homework. Believe me. And that started, blame my oldest daughter. She's in 2nd grade right now, and she comes home with homework that I hate because she hates it. So we're both starting to like mingle a little bit. And I thought, if I only have 60 minutes to talk about something, I can at least give you a bunch of pointers and let you dig into it. And you have all my contact information. So whenever you come across something in the source code, in a slide that you dislike, write me an email, just reach out to me. That's a lot easier. I think I'll be around after the talk anyway for a little bit. So just find me. So yeah, what I'm showing you here is basically what it takes to prepare the read side. And I like this slide in particular because the preparation of the read side tables is something that, first of all, started to look familiar to me. It wasn't OR mapping. It wasn't like just having a couple of annotations on an entity, but at least I know how to create a table, right? So the first thing that really felt familiar to me. And what you see here is actually the Cassandra session. So logom in this case has a very tight integration with exactly one database, and that's Cassandra. If you want to use anything else in logom, probably don't use the persistence API that I'm walking you through here. And that's totally fair. Again, if you have something that's easy enough, don't feel weird by just doing something that we've been doing for 20 years already. I'm not really worried by using CRUD and simple persistence in general. And I'm not going to blame it. I'm just saying that CQRS might work better for you and might be able to have a lot better system architecture in general. So what do we do after we have created our table? What's the next step, like in your applications? Just classical approach.
insert data.
Huh?
Insert data.
We have a lot of data to insert, and it's always the same. What's a prepared statement? Sure, we need to define a prepared statement. And that's the same, even in logom. So next, first, create table. Second, create a prepared statement. That is so straightforward, even I could follow that. Like, that was the first thing I really felt familiar with. There's something that you find in the source code, especially in the demo source code. It's called offsets. I skipped one part in this presentation, and nobody asked about it. So if I say, like, let's say a service dies, and I have to recreate it, including all the data, like the persistent entity data, I have to replay all the events. Assuming a system runs for 15 years, how long that might take, I don't want to even imagine. So there's a way to snapshot in between. And those snapshots are actually called offsets. An offset is exactly the magic behind here. Whenever you come across that, it's something that's another talk in size, probably. And the good news is logom is still in technical preview. And very soonish, I think you will see that logom is able to handle those snapshotting for you. And you don't have to work with that anymore. And that's why I'm not talking about it. Full stop. So we need to trigger those events, right? We need to actually have a kind of a hook into our cargo registered events. And if you look at the registration event and where it's captured, that's all happening in the processor, right? And we're still not at the point where we're actually persisting something in our read side. And I'm already tired, but it is the read side. And that's finally starting to make sense again, because it's just binding values to the prepared statement that we already created, right? So, whew. Yeah, why is that so fucking complicated? And why does it have to be that complicated? I think the most important part, and we kind of touched that topic already, it can be lightning fast for users. Did I really write it is? I did. Unbelievable. It can be. You can totally screw that up. So what you will see if you run the example, when you enter a new cargo into the system, it first of all is kept in memory as information. And if you keep a close eye on the console output, you'll realize that 5 to 10 seconds later, whenever, depending on the load, the actual cargo event processor kicks in and updates your read side of the equation. So the read side is really throwaway data that only gets generated when there's time, when the system has cycles to do that. It's eventually consistent. It's in no means accurate, and you will always have probably a delay. And that's fair, I think. Going back to like the full cycle, why is that so complicated? Because there's a lot going on underneath. All state changes as events, we've seen that. We can replay all events whenever we want to. We can answer a lot of questions with having individual perspectives or read sides. And the read side is actually only eventually consistent. That's something that we just have to keep in mind. But there's a couple of advantages. I mean, when you finally wrap your head around all the new architectural approaches, all around CQRS, you also have a lot of advantages at the end of the day. Just imagine you can recreate bugs. You just take the events log. You replay every single event to exactly the point where the bug appears. Amazing. I've done like a lot of dumps out of production databases and tried and not, and I wasn't allowed to, and I had to rebuild that freaking bug. Just think about migrating systems. Briefly touched already, JSON, changing entity attributes, properties, whatever. You just replay event logs. And that's so easy. You can introduce read sides. You have your persistent entities. You know what you want to store as payload. But maybe somebody comes around the corner and says, seriously, I'm interested in how many containers actually didn't make it to my ships. So how many containers have been scheduled to be on a vessel at some point, and how many actually made it? We probably captured everything that we need to answer, right? So we just have to replay the individual events, process them accordingly, and create a new read side for our application. And you can do that without even having that kind of question before starting to implement. Higher volumes, you can actually cache complete read sides. You can have a super performant application, and because it's only eventual consistent, you can have everything in memory if you need to. And another reason is because the examples I'm showing you are based on logom. And I'm not saying that logom is super complex, but it does a lot more for you, and it does event sourcing. It provides you a couple of specific APIs that you have to learn and that you're not familiar with right now. And this is probably why also the source code samples look a little bit weird from time to time. Have you seen a single annotation somewhere in my code? Not at all, right? That's weird. Anyway, so yeah, you can do a lot more with logom, and having to use a particular framework to actually explain an architectural approach is always a challenge. And you're actually pilot customers today, so I've never done that presentation before. I want all your feedback afterwards on a beer without having that recording stuff here. So you can do whatever you want to do, even with whatever framework you're using as of today, and that works. You've heard that before, logom is amazing. Links and further reading. What else do we have? Give it a try. The one thing that I've found super interesting is actually the cargo tracker example itself. Just reference, go to GitHub, check it out. It's not yet a real activator template. It's just source code, download, clone, whatever. I want all your feedback. This is the CQRS journey parts. So the Microsoft initial free ebook about the whole architectural concept. And I highly recommend to read that. You just need a little bit more time for that than 60 minutes. Another thing that I totally missed to talk about is domain-driven design. So yeah, finding the aggregate roots, which persistent entities actually are, cutting your system into the right pieces, that's not falling out of the sky. You don't have to use domain-driven design approaches, but I highly recommend doing that because it's probably the only successfully proven way to do that, besides just looking into the magic glass thingy or listening to your belly. You heard about Jonah's book. You haven't seen my book probably yet. So the example is described in more detail with a lot more code, with a lot more text. And it's a free ebook, which is solely about the cargo tracker application. And it walks you through every single line of code and every single concept in logom itself. You're totally invited to try that out and also give me feedback. And this is an older, nice little book I wrote, so if you're still stuck on Java E and need to convince your management about switching over to microservices, give that a try. Thank you. That was like my last slide. Happy to answer more questions or just drink more beer with you.
What's your opinion about Microsoft Orleans framework?
Microservice?
Microsoft open source framework, or Orleans?
I haven't seen it, seriously.
It's an actor model.
Okay. I haven't seen it. Yeah.
Yeah, so I was thinking about what you said before, that adding additional commands, adding additional reviews is very easy in event sourcing. And having not actually used that on a production system myself, the first thing that came to mind is, what if I need to change a command? All of a sudden, to perform a certain action, administer IV, let's say, patient records, I need to be a doctor and not a nurse. And so now I have an additional piece of information I need to pass as part of the event. But my previous event logs did not capture that information as like whatever it is, credentials, right? Doctor, nurse, or whatever it is. How do you resolve that discrepancy? Like, do you just say, okay, I'm going to take my snapshot?
You actually have to make that separation in your event processor. So when you build out the read side, you basically need to check if a certain payload is there or not. At the end of the day, it's all payload. That's maybe ends up being JSON and Cassandra or something else. And talking for logom, I mean, I'm basically taking the payload out of the events that I'm replaying to recreate like my entity. And I need to handle everything that could potentially happen, but you're free to actually extend the payload.
Tools like Google Protobuf have they define the schema, and you can update the schema by only appending values at the end. So they've given some thought to it at least.
I'm less concerned about the payload and more about semantic interpretation thereof, right? Like, I'm replaying events, and all of a sudden my business logic has changed as far as like new validation rule, whether or not I reject or accept.
Conceptually, wouldn't they be different? Yeah, and you could have an adaptive
that explode complexity?
Yeah, it's just like API versioning though. So I mean, like effectively, you could have an adapter that transforms version 1 of your event object into version 2, and just treat it like a database migration or something.
I think at the end of the day, the problem is probably not handled in CQRS and then in the persistent side or read side. It's more like in the service cut itself. So doesn't something, maybe you have a new entity that is still like under the same aggregate root and can stay in the same service boundaries / bounded contexts. If not, and if your business model just changes significantly enough, you maybe need to introduce a new microservice or actor or whatever your service boundary is at the end of the day.
So I'm curious, does Lagom have any opinions as far as partition keys as events and commands come in?
Yeah.
Because obviously message ordering matters a lot if I'm updating the same bank account. But if I have like 2 completely separate bank accounts, like being able to parallelize that would be a worthwhile thing. Is that something that Lagom does, or is that
It does, and it works basically with tags. Like there's a tag system underneath.
Okay.
But yeah, cut it out like exactly the same scenario for this talk as offsets.
Okay. And actually, I had a follow-up question on offsets, if you don't mind.
Yeah, sure.
So one of the other things, because effectively what we're doing is we're building a distributed system. And with the distributed system, you become subject to the cap theorem. So you can choose for consistency or availability. You don't want to drop persistent tolerance ever. And this seems like a system that's very much AP oriented with the eventual consistency model. Is there a way to bolt on, let's say, consistency by keeping track of the offset on a partition key level of commands that haven't yet been processed? And using that to say, like, for example, my bank account, let's say my bank account is 1. I just did 10 transactions. I'm only 5 ways through, or 5 offsets through. I have 5 more to go. So before actually allowing that read operation to complete on my API, I need to make sure that my event log catches up. Is that like a pattern that's possible in Lagom?
At the moment, I can't think of a way to do that, but I assume as you have access to the offset via the Cassandra session, there has to be at least a way to figure out about the offset and probably hook into that, but there's no like official way, and I haven't even seen an example yet.
Yeah. We'll do that, like with Kafka, we'll do that either in Kafka natively or we'll do it with console. So we'll treat like the latest offset per partition key.
As soon as you switch off recording, we can start to talk about future plans.
Okay. Yeah, I have permission to edit out whenever I want to.
Fair. We're still official, sorry.
What would you say are some of the primary advantages of using CQRS over like the traditional?
I think the significant advantage is definitely speed. Is absolutely speed. Without users noticing, you can have the most complex operations underneath, and your system is very, very responsive if you follow that message-driven / event-driven architectural approach. And again, CQRS is only something that supports you building a complete application in that architecture.
Under that, I would say data loss. You don't know what your business will need in the future. So if you're tracking events, you're tracking every event, you're losing no data.
You have a time machine.
Right. You can say, oh, in the future, my business wants to know X. I just have to replay my events and build the projection. You don't have so many data loss. If you're doing straight updates, you are.
There are a couple of advantages in general. I think depending on whom you ask, right? So users want to have like always responsive systems. Business wants to evolve their business models as quick as possible. That's another advantage. I mean, whatever read side, and that particularly relates to the read side of the equation, that's throwaway data at best. So your core information is like in the events log. And whatever you want to have answered in like 5 years. As long as you have your events log, you can even go back to 1918 or whatever and just come up with answers that you never were able to ask while starting to write the application. So that's definitely a business advantage.
So like data warehousing and transaction.
I wouldn't say it's data warehousing. It's maybe it's something that you could at least use as a thought model to understand that a little bit better. Yes, it's kind of like recreating a particular view on your data via the read side. I can distantly go with that as a thought model at maximum. You've been next, right?
Yeah, so if you have a number of microservices within your organization, some processes are sending commands, others are receiving those as events. In one of the slides you said that commands are something command and events are past tense. So I mean, you seem to be using two different objects. And I've seen that advice elsewhere, I think in DVD or something. So if you're designing a system, do you, for each event, which will eventually, or each command, which will eventually become an event somewhere else, are you actually creating two classes that contain the same information?
It's basically inner classes. So it's not separate class files, but it's inner classes of the defined in the Logom framework. Those examples are heavily driven by the persistence API of Logom in this case, and I have a hard time to map that into like the original theoretically concepts behind that. Well, yeah, give it a look at the source code. I think that will explain a lot more. Yeah.
How does Logom or CQRS handle multi-node clusters in general? You were talking about how events are stored in memory, or read events are stored in memory. So do you still have to worry about like replicating caches and things of that nature?
Yeah, I don't, because CQRS is an architectural concept and they won't ever. Logom builds on top of Akka and Play. And Akka, the interesting part is actually Akka cluster plus Akka persistence. And those two take care for whatever you see on the Logom API side. And I actually can't answer that down to the individual Akka functionality right now. But long answer, short, it depends on the framework you're using. And Logom has a way of doing that, and we're obviously guaranteeing that. Yeah, go crazy.
This is going to sound like I'm trolling. I'm not. I'm just kidding.
Wait.
So from a high-level archetypal standpoint, how would you contrast Lagom's approach to something like CouchDB 12 years ago, where you basically, on insert, you had a series of views that would operate over that and determine whether or not that mapped to a specific result set that was sortable or something like that?
Oh, I won't compare that at all. So the way Logom implements CQRS, or CQRS in general, is something that every distributed relational database does at the end of the day, inside. So when they talk like Oracle database, when Oracle is talking about transactions, they actually implement that internally via CQRS, and they are just encapsulating the complete complexity away. And, and the cost for that actually is performance at the end of the day, right?
Right. Well, I get from like a use case standpoint, when I'm developing a CouchDB app, at insert time, you sort of have to figure out the way that data needs to be retrieved from the system. Then you have n number of functions that operate on data at insert time to either place an object into a view or not. I guess from the standpoint, I'm just seeing a parallel between what we were describing with Lagom, where you have a write operation and you have a series of listeners that are operating on that. And you know, one of the challenges with that, with CouchDB, was that you ended up having to add a lot of complexity to optimizing the query performance at read time, not to cause writes to get super long. And I'm curious if there's been like any consideration of that, or any if that's come up in any real world use cases yet?
Couple of answers.
Yeah, I know, there were a couple of questions, sorry.
Oh, Arun is coming like what, next week? Grill him. I don't know Couchbase at all. All I know is, of course, you can also have like stored procedures, event triggers in an Oracle database, right?
Yeah.
And
But it becomes the only way that you can get data out. I'm talking classic CouchDB before the whole Couchbase thing.
can't.
Yeah.
And I grill Arun. Sorry, I'm out. CouchDB is nothing I've ever had in hand, and it doesn't look like I want to.
There are reasons.
Fair. Yeah.
I think one of the original slides during the presentation, you were showing multiple databases, right? But I don't think it necessarily means a complete separate instance. It can also be a separate schema within the same instance. Is that a true statement?
That's true. So that was more like a conceptual approach, which should highlight, which is obviously not working, and taking that as positive feedback at that point. Depending on the read side that you want to present, there might be a reason to use a document database, whatever, NoSQL-like thingy, or even a relational database. And that was just meant to use the right tools for the right jobs. When you're working with Logom and you're working in local development mode, exactly that happens. So you have like one Couchbase instance. It's not Couchbase, it's Cassandra. See that? What? Jesus, thank you. You have one Cassandra instance with various schemas for the individual services. That's exactly what happens. Yeah.
Okay, we have room for one or two more questions.
Yay, more beer for me. Thanks for coming. Thanks for staying awake.